Hey, I didn't see you walk in. Huh, that's stupid. Okay. Today I'm just going to introduce complex numbers to you so that on Friday we can start talking about finding complex roots of polynomials. Super fun. So let's get to it. You all know how to solve an equation that looks like this. We can factor it. An easier way would be to add 1 to both sides, take a square root, and we get plus or minus 1. But in math, if you think about this equation, x squared plus 1 equals 0, how do we solve this? If you subtract 1 from both sides, you get x squared equals negative 1, which we know is not possible. We square anything, it's positive. So there is a branch of mathematics that deals with this, the square root of negative 1. Square root of negative 1 we call I. Surprisingly, imaginary numbers are very useful in the real world. I'm not going to get into it, but for something that we call imaginary, it's wild how they can be used in the real world. But anyways, some things about I. Well, I to the first is just I. I don't want that to confuse you or anything. But I squared, which is the square root of negative 1 squared, is negative 1. That's really the key thing to everything. If you can figure that part out, it's all gravy after that. If you care, I to the third is negative I, and I to the fourth is 1. And if you did I to the fifth, it's I, and then I to the sixth is negative 1. It's a pattern that just repeats itself every 4 times. It's pretty cool. But I squared being negative 1 is the part that you have to understand. What is a complex number? So that's coming up next. A complex number is a number in the form a plus bi, where a and b are real numbers. So numbers that we're familiar with, that we use all the time. Integers, rational numbers, irrational numbers, all of those are real numbers. This a is the real part. This bi is the imaginary part. And together, the real and imaginary parts make our complex number. So when I say complex number, I am referring to both the real and the imaginary part. So if you were to think about it, every number that we use is a complex number. All real numbers are complex numbers, because if you had the number 2, well, that's just 2 plus 0i. Or if you had like pi, it's pi plus 0i. All numbers are complex numbers, but that's not the biggest deal in the world. What are we going to be doing with them in the near future? What we're going to be focusing on is conjugates. So this is something you will need to know for later this week. The conjugate of something like a plus bi is a minus bi. And similarly, if you started with a minus bi, the conjugate is a plus bi. Basically, you take the opposite of the imaginary part. And why do we care about the conjugate? For us, it's going to help us get rid of imaginary things. So when we have an imaginary solution to a polynomial equation, we might not even see it. So here's what I'm talking about. Let's say we have zeros of 2i and negative 2i. What we're going to be doing on Friday is this. We're going to be saying, well, if I were to write that in a factor, it'd be x minus 2i and then x plus 2i. And you might be thinking, well, why don't we see i's ever in our polynomials with this stuff? If you multiply this all out, we get, what do we get? We get x squared plus 2ix minus 2ix minus 4i squared. You will notice that the parts with just I always cancel with these conjugates when we multiply them together. And I squared, that's negative 1. So cleaning this all up, this is x squared, negative 4 times negative 1 is plus 4, positive 4. Even though we have two imaginary answers, our polynomial, which you would get from them, I guess, doesn't have any i's in it. So I'm going to show one more conjugate thing. It's a little bit harder to work with, but let's check it out. Let's say you have complex zeros, and this one's going to be tough, of 1 plus I and 1 minus I. So we do x minus the first one, and x minus the second one. Those are our two factors. And then this gets into a lot of multiplying out. So I'm going to distribute that minus so I don't make any silly mistakes. X minus 1 minus I, and then x minus 1 plus I. Multiplying this out, x times x is x squared, x times negative 1 is negative x, plus xi, onto the negative 1 distributing. Minus x plus 1 minus I, and then onto the negative I distributing. Minus xi plus I minus I squared. Now with conjugates, the whole idea is that all the i's, all the imaginary parts, go away. So this xi will cancel with this minus xi. This I will cancel with this minus I, and minus I squared is minus negative 1. Therefore, we would have no imaginary parts left. In fact, I run out of space here, but this cleaned up is x squared minus 2x plus 2. So from this polynomial, which looks like something we've worked with before, you get imaginary zeros. So this is what we're going to be working with on Friday. If you want to talk to me, you can do that. Have a great day.